about Ebola so far. Has anybody heard of anybody that has been in contact with any of the people that have been up here in Cleveland?
Unfortunately, they sent an email where I work saying that someone who works for my company in our Akron area had visited with the young lady.
Oh no.
Ebola, and they're allowing that employee and one other employee to stay home for the next
21 days. Yeah, that's what I heard about Kent State too. No, that Kent State had 3 employees that came into contact with the person who had it. So they are sending them home for 21 days. And they're basically in quarantine. They're not allowed to come out. So, yes, son?
There's a bubble.
Okay. Continuing on today with what we had been discussing the last time. We had been talking a little bit about traits and about chromosomes and about our genes. And so if I turn off this light, you can probably see this better. Not that one. That one. That one. All right, it's looking better today. When I was describing what was going on with the green screen, somebody said, oh, you need to tell the audiovisual people because probably the bulb is going out. So thankfully that didn't happen in the middle of class last time. So in discussing the 9,000 genes that we have that control different traits, now we talk about genes that are controlling multiple traits. So one of those traits is height. And so there used to be an old wives' tale that if you were going to predict how tall your child's height was going to be. If the baby was a boy, you add 5 inches to the mother's height and average that with the father's height. Or if it's a girl, subtract 5 inches from the father's height and average with the mother's height. And then another culture says that you take the child's height at 2 years and double it. But nobody's ever found an exact science to be able to figure out how tall you exactly are going to be, how much you're exactly going to weigh, because those things are controlled by multiple genes. And so what that has, or what that's called, is a polygenic trait. Poly meaning many, genic meaning genes. So polygenic is controlled by many genes. And so in this case, we also have what's called an additive effect. So with height, you don't just have tall people and short people. You have all kinds of people in between. And so the tall gene may be due in part to genetics and then also to hormones and to bone length, which is controlled by environmental factors, and then to how fast or how slow you're growing and what happens to you during those developmental years. So what happens when you have an additive effect is where you have something that's controlled by many traits or controlled by many genes, and then all of those environmental factors on top of it contribute to the ultimate phenotype. And so here's another example of one of those traits, and this one is for skin color. You can look this one up online. It's really interesting to see how all of these different alleles are going to influence the way that you are ultimately going to have skin color. And then, of course, it's going to be influenced by the environment. So it is actually mind-blowingly complicated to attempt to do a Punnett square. We just did really simple Punnett squares with like big H, little h, little h. These are many, many genes, so that's why we have so many possibilities coming out of polygenic traits. So another really interesting polygenic trait is autism. Autism was in the news there for a while because people were thinking that vaccines caused autism. But what we've actually found is that there are between 10 and 20 different genes that contribute to autism. And then it may also be an environmental factor on top of that. So autism involves between 10 and 20 different genes. And you've probably heard of the autism spectrum. If you've ever heard of autism spectrum, it means that children can go from just having very mild autism to having very severe autism. And so one of the traits that's involved, or one of the things that people notice about people with autism, is that they often have unusual abilities with perception. Sometimes they're very, very focused. Sometimes it's hard to get their attention. They may have extreme analytical skills. If any of you have ever seen the movie Rain Man, you saw somebody that was on autism spectrum. They may have very, very sharp focus. And so this is something that has actually been studied and was called the geek theory of autism. And basically that between those 10 and 20 different genes coming together and making someone who has severe autism, well, it could also be that the result of having two very intelligent parents could be that you have a child that's either very intelligent, right on the edge of being on the autism spectrum, or that environmental factors could push them over and put them on the autism spectrum. And so when we have genes that are controlling things like perception, perception to all of us, we perceive what's going on around us, but to somebody who has autism, they may experience the world in a completely different way. Or we may have the inability to focus. Somebody who's got autism may either have very uber focus, so they're very focused, or they may be unable to focus. And so they ask the question, why might computer nerds be more likely to have autistic children? It could be because those same genes go into making somebody very intelligent, and then two intelligent parents come together and have a super intelligent child. Or it could be that environmental factors push the children over the edge onto the autism spectrum. And there's so much research out there, there's so much misinformation that I think that this is one of those things where people say, oh, maybe vaccines had something to do with it. It may be that vaccines are that environmental factor that switches on those genes in order to cause autism. But it is not vaccines causing autism in somebody who never had it, never had the genetics for it before. So it's a really complicated topic, as genetics are a complicated topic.